Good afternoon, all of you. Thank you for joining. There is a slight change. Probably in the agenda you would have seen a minor safety one, but what we are presenting today is a digital pipeline defect and corrosion management solution. It's a SAP Leonardo-based solution, leveraging machine learning services as well as IoT. So once we started again looking at the industry challenges, which typically the oil and gas pipeline transportation industry faces. Essentially, if you see that the pipelines, these oil and gas pipelines run through miles of harsh terrain and they run through remote areas, remote locations, right? So continuous, again, monitoring of these pipelines for the health of the pipelines, for any kind of, say, corrosion or for any kind of defects, like a leakage or a dent, or let's say even the surface coating erosion, which leads to rust. Even in some countries, encroachment is a problem around the pipelines. So for avoiding, again, for these require continuous monitoring. Now that's a serious challenge because the pipelines are running through long miles of harsh terrain. So prevalent in the industry today is manual inspections. It is more of a time and frequency-based manual inspection. What it means is manual inspection actually means people going over and looking at these problems. Now these are remote locations. These are many a times pipelines run through heights, so you have to cut through the pipelines for inspections. So these become hazardous to even the person who is the worker who is going for the inspections. So these lead to many a times lead to safety incidents. And last but not the least, any oil and gas pipeline burst is a serious environmental hazard, right? So many countries have very strict regulatory norms against these, and it may lead to heavy penalties for the pipeline companies. So looking at these challenges, then when we tried to address some of these challenges in the solution that we built, which is our digital pipeline defect and corrosion management solution. The key tenets that we tried to address through this solution was we wanted continuous monitoring of the pipelines, or real-time or near real-time monitoring. Now monitoring would involve data through sensors, and in our case it's a two-phased or a two-structured monitoring. One is a drone-based monitoring and the other is through sensors. So the drones fly over the pipelines and they will monitor the external surface of the pipelines. Sensors are more of detecting, again, the thickness of the walls of the pipeline, and they are inferring whether there is some internal corrosion or not. So real-time monitoring, you get the data. Based on the data, we will do a failure prediction. Say in the next 2 months or 6 months, will it fail? The pipeline is likely to fail. And based on those prediction algorithms, the dates that it gives to us, you may want to plan your job, your inspection routine, and the corrective action that you want to take on these pipelines. So when it comes to planning, again, this entire application is built on HANA, on SAP Cloud Platform, using Leonardo services, and it integrates back into the S4 HANA backend ERP system. When it comes to planning of the work, creating a notification, creating a work order, and taking it through this entire life cycle, it is done in the backend system. So there is a integration. There is an IT-OT integration which is there in play. Some of the solution features, very quickly I just again touched upon the visual inspection piece. There would be self-guided drones. Again, they would be fed in their flight parameters, but the drone has inbuilt algorithms. It will track the pipe. So it will keep tracking the pipe and moving over the pipeline. It will not move away from the pipeline. And then the drone will also do a first level of analytics. It will say, okay, it will try to track anomalies in the pipeline, that there are some problems in the pipeline, some sort of a defect which is there, but it's not able to identify those. So it tracks those anomalies, it takes images, and then it sends to the cloud platform where we have a machine learning model which actually recognizes what kind of a fault it is. Let's say it's a rust, or there is a paint peel. There is again that surface coating has come out, so it will detect that. Or there is a dent on the pipe, or there is an encroachment around the pipe. It will detect those things. The other piece is the using ultrasonic sensors for measuring thickness of the pipe wall. What it helps is there would be the drone covers the external pipe piece. Now internally also there would be corrosion, right? How we want to measure it is we want to measure the thickness of the pipe through ultrasonic sensors, and any reduction on the thickness of the pipe essentially means that there is a corrosion happening within the pipe, and you need to do that further inspection. Based on these data, we will do a failure prediction. We have used an open source R algorithms to do the failure prediction as to how much into the future the pipe is likely to fail. And then, based on the predictions that we get, we do the maintenance planning. Now, when an operations manager is trying to do a maintenance planning, they also have the visibility here to look into similar kind of defects which have happened in the same region, and what kind of solutions were taken to address the problem. They can see those through the application and then optimally plan their maintenance plan, that what kind of solution should be adopted to fix this kind of an alert. Once they have decided on the maintenance plan, they will trigger a maintenance notification which is in the backend S4HANA system. So this is SAP Cloud Platform on HANA using Leonardo, and then we are also leveraging S4HANA system. We have dashboards, reports against similar defects. What are the defects by region, by severity, by the classification, and everything is on, as I mentioned, it's on a UI5, SAP-based UI5 application on SAP Cloud Platform. Okay, and we are using your SAP Cloud Platform IoT 4.0 services, SAP Leonardo machine learning services. A very quick data flow before we jump into a very short demo of the solution. We just mentioned drones take images of the pipeline, external surface, if they find any anomalies. Then they send it to the gateway. Once they are running over the pipeline, at certain distances there will be IoT gateways. So the drone will have limited capacity or storage capacity. So it will keep taking images, and as and when it comes across gateways, it will dump all those images into the gateway. And the gateway will be connected to the internet, and it will be sending those images into SAP Cloud Platform. Similarly, sensor data, we are continuously taking the sensor, feeding in the sensor data into the gateway, and from the gateway it goes into the cloud platform. From the cloud platform, there are two tracks again, two treatments per se. Like for the drone, all these images will be sent to the machine learning model, which is on Google TensorFlow, which is built on Google TensorFlow and hosted on SAP Leonardo. So all these images are fed into the model where it identifies what kind of a defect it is. So it will identify what kind of a defect it is and throw the alert based on that. And then you take corrective action. Sensor data, you get the sensor data, and then we use our algorithms to predict how much into the future there is a likely chance of failure happening of the solution. With both these inputs, now you see those alerts in the application, and then you can decide, the operator can decide whether to, how best to plan their maintenance activity, whether to create a notification or a work order into the backend system and then take it from there. Okay, so let me quickly jump into the demo. Okay, I need some help. How do I get into the desktop on this? Okay. So what you are seeing here is the drone flying over the pipeline. And you see these boxes. So the drone is actually using its own algorithm here to track the pipeline. So if the pipeline bends, the drone itself will bend through as well. So it is tracking the pipeline and it self-guides. It's a self-guided drone. On top of it, you see these red marks. These are actually the anomalies that the drone is finding. That on the pipe, this does not look to be good. There are some problems in the pipeline. Once it identifies these problems, these images are being captured by the drone. And then, as we discussed, it sends these images into the SAP Cloud Platform, where it runs it through the machine learning model that we have built. That machine learning model has been trained and it has been built on. So the machine learning model will then throw different kinds of defects. Whether there is a rust on the pipeline or there is a dent on the pipeline, it will classify those defects. Okay. So what you see now here, for the operator, again, this is in India, this is a state view. So this is the state view, various states from which the pipeline network is flowing. So an operator may be responsible for their specific areas. They may not be responsible for all the states. So they would be interested more in their specific areas. But what you see here is there are 4 states from which the pipeline is flowing. The red alerts, there is a red and there is an amber alert. The red alerts means there are new alerts which have been thrown by the drone flying or the sensors. Again, there are new alerts. They have not been, no action has been taken upon them yet. The amber ones are where there is some action taken, action in the form of a work order which has been created already. There is some action happening. So that's what it shows. It gives you an overview and a snapshot of the overall, again, alerts and work that is happening across the pipeline network. You see the alert analytics piece here. So once you go, that is, we talked about those trends and analysis, right? This is what it shows, that there are so many alerts, alerts by severity, alerts by region, alerts by classification. When I say classification, whether it is corroded or there is a dent or there is any pipe peel off, so you can see those things. And you can directly from here itself, you can go and actually do further investigation of the problem. So here we have clicked onto this. Okay. So it is directly taking you to the alert screen where it shows that this is what was detected by the drone, and then through the machine learning model it has said that there is a rust which has happened. We will come back to this. Okay. So now as an operator I am responsible for this area. I have clicked onto this. What you see is, we will zoom on and you will see red and amber you know right now, right? What new and work in progress. Now these are image-based alerts which have been received from the drone, and these are sensor-based alerts which are received from the sensors. So that's the classification. The image-based alerts you could see. So it has identified there is a dent. Okay. So there are a few things that we need to, it has identified that there is a dent here. It has also identified It has also identified this pipeline, which pipe section does it belong to. This pipe section is nothing, it is actually in the backend S4HANA system. It is being drawn out. So the entire pipeline network has been, the source of the data, master data is in the backend S4HANA system. So every organization will have their entire pipeline mapped on the S4HANA system, and it is then taken in, you are mapping it back into this application on cloud, on SAP Cloud Platform. So essentially it is taking the geo coordinates of the images. It gets the address of the image, where exactly the fault is, and at this location, so which pipe section does it belong to in the backend system. So why is it required? Because again, this pipe section, there is a work order created in the backend system. It also gives you, again, list of similar defects. This is a dent. There is a dented image again. And just before this, you click on this and it gives you the work orders created, what kind of solution again was taken, corrective action was taken. From here, the operator can decide to create a notification as well, if they decide, or they can say that, okay, this is not a problem, this is a problem with the model, machine learning model. They can reject it. Okay. So there is a notification fixed set of tasks. You can select the task and then you create the notification. And this notification gets created in the backend S4HANA system. So you will now find that this has become amber. The same alert, it has become amber. There is a notification number which has already got created now. Okay. So we will quickly go to the sensor-based alerts as well now. So this is the network. So all the sensors are placed on the pipeline network. Here there are some alerts. So this is what, again, this is based on past 24 months data. So the last 12 months data you are seeing, this is the trend, and there is the minimum threshold thickness of the pipeline wall. So this, based on the past trend, 24 months trend, our algorithm is predicting what will it be in the next 6 to 12 months. And see, if you see this amber, this is the predicted value, and then it becomes red after 2 months. So it essentially says after 2 months, there is a likelihood that it will go below the threshold value. And then we have defined some logic here that anything which is failing in a month's time will be high severity, anything which is failing between 1 to 3 months is a medium priority, and anything failing between 3 to 6 months is a low priority. Anything beyond that, we are not considering. So anything up to 6 months, and then based on the priority of the alert, the operator may decide what next actions to be taken. They can create a notification and then take it from there. So this is the solution that we have built. It's kind of an extension of the S4HANA system on cloud, SAP Cloud Platform using SAP Leonardo services. So I am done with my basic piece. Any questions? Yes.